In the previous video, I explained exercise 1 of a 6 problems. So in this, we are going to discuss 7th problem. After finishing this 7th problem, again we are going to discuss the concept of inverse functions and complex functions. So okay, the question is, if f of x is equals to cos of log x, then show that f of 1 by x into f of 1 by y minus 1 by 2 of f of x by y plus f of xy is equals to 0. So to make this problem easy or to understand it easy, I will solve one by one term. First I will solve f of 1 by x. F of 1 by x. Here in the question, f of x is equals to cos of log x and we want f of 1 by x. It's very simple. In the place of x, we need to substitute 1 by x. So cos of log, here in the place of x, 1 by x, which is equals to cos of log 1 by x can be written as x power minus 1. Now this is in the form of log a power m, so this power will come to the front, that is minus 1 into cos of log x. This is f of 1 by x value. Now again one more, we have f of 1 by y. So f of 1 by y is equals to cos of log, in the place of 1 by x, let us substitute 1 by y. So if you observe this previous step and here cos log, here 1 by x, here 1 by y, only in the place of x, in the place y we need to substitute. So direct answer I am writing minus 1 cos of log x is there, so here we will get log y. So this total first term is f of 1 by x into f of 1 by y. Here f of 1 by x value is there, here f of 1 by y value is there. So let us multiply both. F of 1 by x into f of 1 by y equals to minus 1 cos of log x into minus 1 cos of log y. Here minus into minus plus, 1 into 1 1. So we remains with cos of log x into cos of log y. Here cos into cos, we should not write it as cos square because here it is log x, here it is log y. Without this log x and log y, this cos does not have any value. So this is simply cos of log x only, this is simply cos of log y only. Don't combine this and don't write it as cos square of log x log y something. Okay, now this total first term completed. Now if you observe the second term, here we have 1 by 2. 1 by 2 don't have any problem with this. So let's keep it like that only. F of x by y plus f of xy. So let us find the value of f of x by y and f of xy. In the question, f of x is equals to given as cos of log x. Now we want f of x by y. F of x by y. So in the place of x, we need to substitute x by y. So we get cos of log, here x is there, so in the place of x, we need to substitute x by y. So here if we observe this RHS, cos of log x by y, log x by y is equals to log x minus log y. Again this is in the form of cos of a minus b, cos of a minus b. Here a is nothing but log x, b is nothing but log y. So cos of log x minus log y is in the form of cos of a minus b. What is the formula for cos of a minus b? Cos of a minus b is equals to cos a cos b plus sin a sin b. So wherever we have a, we need to substitute log x. Wherever we have b, we need to substitute log y. So cos of log x minus log y, that is nothing but f of x by y. F of x by y is equals to cos a, cos log x, cos b, cos log y, plus sin a, sin log x, into sin b, sin log y. So we got the value of f of x by y also. And we need to find the value of f of x into y. Okay, in the given question, f of x is equals to cos of log x. Now we are finding f of xy. So simply in the place of x, we need to substitute xy. So we get cos of log in the place of x, xy. So cos of log xy is equals to log x plus log y. Now this is cos of log x plus log y. It is in the form of cos of a plus b. Cos of a plus b is equals to cos a cos b minus sin a sin b. In the place of a log x, in the place of b log y. So f of xy is equals to cos a cos b cos log x cos log y minus sin a sin b sin log x sin log y. So totally we got f of 1 by x value, f of 1 by y value, f of x by value, f of xy value. Let us substitute all these in the formula, I mean in the question which he gave. Okay, we need to show that f of f1 by x into f of 1 by y minus half of f of x by y plus f of xy is equals to 0. So already we solved f of 1 by x into f of 1 by y. That value is cos of log x into cos of log y. F of 1 by x into f of 1 by y value cos of log x into cos of log y minus half into f of x by y plus f of xy. Just now only we solved f of x by y. Here cos x log x cos log x cos log y plus sin log x sin log y, whereas f of xy value is cos log x cos log y minus sin log x sin log y. So here we want f of x by y plus f of xy. So these two terms addition, I will do that. So here under f of xy only I am writing f of x by y value also. F of x by y value is cos log x log y plus sin log x sin log y, and we want f of xy plus f of x by y. So I am doing addition of these two equations. Minus sin log x sin log y plus sin log x sin log y, both will get cancelled. So we remains with cos log x cos log y plus cos log x cos log y. So it is there two times. So we get 2 into cos log x cos log y. This is the value of f of xy plus f of x by y. I will substitute this. 2 cos log x cos log y. 2 cos log x cos log y. Here 2 will get cancelled. So we remains with cos log x cos log y minus cos log x cos log y. This total term is cos log x cos log y. This total term is cos log x cos log y. So both are equal. Minus symbol is there. So both will get cancelled. We remains with 0. Hence proved. Okay, we completed exercise 1 of A. Now after finishing that exercise 1 of A, the concept is inverse function and composite function. So let us discuss some examples from the textbook. This is example from textbook. If set A is equals to 1 2 3 and set B is equals to A B C, then the function is given as 1 comma C 2 comma B and 3 comma A. So this function I am representing with the figure. Here we have set A 1 2 3 and set B is given as A, B, C. 1 comma C. So 1 to C, 2 comma B, 2 to B, 3 comma A, 3 to A. Is a bijection bijection from A to B. So he said that it is a bijection. So first let us confirm whether it is a bijection or not. Otherwise, if it is a bijection, how he is saying it is a bijection. So to be a bijection, the function should be one function as well as onto function. One function as well as onto function. If a function is one function as well as onto function, then only it is called as bijection. So first let us check how this function is 1 1. 1 is connected to only one element C. 2 is connected to only one element B. 3 is also connected to only one element A. Every element of a set A has only one image from the set B. So this function is 1 1. Next, how this function is onto. What is the definition of onto function? If the codomain of a function is equals to the range of the function. In this function, what is the range? Every element of set B who has connection with set A or range. So element A has connection, element B has connection, element C also has connection. So the range will become A comma B comma C. Now if we observe the codomain, he said that it is a bijection from A to B. So this second set will become the codomain. So second set B is equals to ABC. Codomain is ABC as well as range also ABC. Codomain is equals to range. Then this function is also onto. The given function from A to B is 1 1 as well as onto. Then it is bijection. Next, and F inverse is given as A3 B2 C1 is also a bijection from B to A. So function F is there. For that function F, he wrote F inverse. Whenever we have ordered pair, it is very easy to write the inverse of it. Simply here 1 comma C is there. Exchange these. C comma 1. Here he wrote. 2 comma B is there, B comma 2, here B comma 2. 3 comma A is there, here A comma 3. So simply every ordered pair X and Y coordinates we should interchange. Then those will become inverse. So function F is 1C, then inverse will become C1. Here 2B, inverse will become B2. Here 3A, inverse will become A3. Now for this function, I mean inverse function, I will draw the figure again. He is saying is a bijection from B to A. So this will become set B and this will become set A. So in the set B we have elements A, B, C, and in the set A we have 1, 2, 3. So A to 3, A3, B to C1. So first, to check whether it is a bijection or not, we need to check 1 1 function as well as onto function. First, for checking 1 1 function, A is connected to only one element, B is connected to only one element, C is connected to only one element. Every element of set B has connection with only one element of set A. Otherwise, every element of set B has only one image. So it is 1 1 function. Next, checking for onto. Onto means a function codomain should be equals to the range. Here range is 1, 2, 3. And we are checking the function from B to A, so then A will become the codomain. So set A is 1, 2, 3. Here codomain is 1, 2, 3 and range is 1, 2, 3. So codomain, range both are same, so then it is onto function also. If the function is 1 1 as well as onto, then obviously it is a bijection. Okay, let's move to the next example. Okay, the next question is, if set A is equals to 1, 2, 3, set B is equals to A, B, C, D, then F is equals to 1C, 2B, 3A is a injection but not a surjection from A to B. So this is set A and here it is set B. Set A has 1, 2, 3 and set B has A, B, C, D. 1 comma C, so 1 to C, 2 comma B, 2 to B, and 3 comma A, so 3 to A. He is saying that it is an injection. So first let us check whether it is injection or not. 1 is connected to only one element C, 2 is connected to only one element B, 3 is connected to only one element A. So every element of set A has only one image, so it is 1 1. Next, surjection. Of course, 1 1 injection, both are same. Surjection, otherwise onto. Codomain should be equals to the range. Here what is the range? Range of this function is A is connected, B is connected, C is connected, but D is not connected to any element. So range will become A comma B comma C. Whereas the codomain is B. A, B, C, D. Codomain is A, B, C, D, but range is A, B, C. So range and codomain both are not equal. So that's why it is not onto function. The same he said as not a surjection. Surjection onto both are same. Next, F inverse. C1, B2, A3 is a relation from B to A. From set B to set A now. Set B and here it is set A. Set B elements are A, B, C, D. And set A elements are 1, 2, 3. And connection. F inverse is given as C1, C1, B2, A3. Now, if we observe this clearly, first, what is the definition of a function? Every element of the first set should have an image. Compulsory, that is, then only it is called as a function. If we observe here, from the set B, element A has image, element B has image, element C also has an image, but element D does not have any image. So that's why this is not a function. It is simply a relation. The same he gave as F inverse is a relation from B to A, but not a function, because D belongs to B. D is an element in the set B, has no F inverse image. For this D, image is not there. So this element D, which is from the set B, should have an image, then only it will become a function. But here the element D does not have any image, so this is not a function. It is simply a relation. Okay, next question. If set A is equals to 1, 2, 3, set A has 1, 2, 3, and set B has AB, and F function is given as 1 comma A, 2 comma B, 3 comma A. Now if we observe this clearly, 1 has image A, 3 also has image A. 1, 3 both are having the same image A. 1 has image A, 3 has image A. 1 and 3 both are having the same image A. So that's why it is not 1 1. It is not 1 1. So that's why he gave not an injection. Injection is nothing but 1 1. But he is saying that it is a surjection. Let us check. Here what is the range? A comma B is the range, because A has some connection, B has also some connection. So A comma B is the range. So range is equals to A comma B. Then what about the codomain? Set B is the codomain, so set B is equals to A comma B. Codomain A comma B, range also A comma B. Codomain is exactly equals to the range, so then it is onto function. Onto is nothing but surjection. It is not 1 1, it is onto, so that's why it is not bijection. Because to be a bijective function, it should be 1 1 as well as it should be onto. Next, F inverse he wrote from B to A. Here set B, here set A. Set B has AB and set A has 1, 2, 3. Now F inverse he wrote as A to 1, B to 2 and A to 3. If we observe clearly here, element A has two images. One is A comma 1 and one is A comma 3. According to the function's definition, every element should has only one image. But here element A itself has two different images. So that's why this is not a function. The same he gave. It is a relation from B to A but not a function from B to B, because A belongs to B. There are two images. For element A, two images are there. One is 1 and one is 3. So no element should have two images. So that's why this is not a function. It is simply a relation. Okay, example problems completed. Now let us move to solved problems. Okay, the first question is, if f is a function from R to R and g is a function from R to R are defined by f of x is equals to 4x minus 1 and g of x is equals to x square plus 2, then find the value of g of f of x. Here g of f of x can be written as g of f of x. So g of f of x is 4x minus 1. So g of 4x minus 1 is nothing but this 4x minus 1 value we need to substitute in g of x. So here we have g of x is equals to x square plus 2. So in the place of x we need to substitute this 4x minus 1. G of x is equals to x square plus 2 and we are finding the value of g of 4x minus 1. It is very simple. In the place of x we need to substitute 4x minus 1. So here x is there. So in the place of x 4x minus 1. Here square plus 2. So if we expand it, this is in the form of a minus b whole square. So a minus b whole square is equals to a square plus b square minus 2 into a into b plus 2 as it is. So 4x whole square 16x square plus 1 square 1 minus 2 into 4 into 1 8x plus 2, which is equals to 16x square minus 8x plus 1 plus 2 plus 3. So g of f of x value is 16x square minus 8x plus 3. Okay, the next question is, what is the value of g of f of a plus 1 by 4? So this can be written as g of f of a plus 1 by 4. If we observe the previous question, in the previous one we solved the value of g of f of x. So that value I am writing. G of f of x, which we solved in the previous problem, that is equals to 16x square minus 8x plus 3. Now if we observe these two clearly, g of f of x value is 16x square minus 8x plus 3, and now we want the value of g of f of a plus 1 by 4. So simply in the place of x we need to substitute a plus 1 by 4. So g of f of a plus 1 by 4 is equals to 16 into, in the place of x, a plus 1 by 4 whole square minus 8 into, in the place of x, a plus 1 by 4 plus 3, which is equals to 16 into, here square is for numerator as well as for denominator also. So we get a plus 1 whole square divided by 4 square minus 4 ones are 4 twos are 2 into a plus 1 plus 3. Here 4 square is nothing but 16. So this 16 both will get cancelled. So we remains with a plus 1 whole square. A plus 1 whole square is nothing but a square plus 1 plus 2a. Here minus 2 into a minus 2a minus 2 into 1 minus 2 plus 3. Here plus 2a minus 2a cancel. So remains with a square 1 minus 2 minus 1 minus 1 plus 3 plus 2. So the value of g of f of a plus 1 by 4 is a square plus 2. Okay, the next question is f of x, that can be written as f of x. F of x value in the question he gave it as 4x minus 1. So f of x value is 4x minus 1. Then what is the value of f of 4x minus 1? It means in the place of x we need to substitute 4x minus 1. So f of 4x minus 1, here 4 as it is, in the place of x we need to substitute 4x minus 1. This minus 1 as it is, equals to 4 into 4x, 16x minus 4 into 1, 4, here minus 1 as it is. So we get 16x minus 4 minus 1 minus 5. So the value of f of x is equals to 16x minus 5. Okay, the next question is g of f of 0, that can be written as g of f of 0. So in the previous problem we solved f of x. F of x. In the previous problem we got the value as 16x minus 5. Now here we want f of 0. So f of 0. In the place of x we are substituting 0. So 16 into, in the place of x, 0 minus 5. 16 into 0, 0 minus 5, nothing but minus 5. So f of 0 value is minus 5. So g of f of 0 is minus 5. So now we want g of minus 5 value, and here g of x, he gave the value as x square plus 2. Now we want the value of g of minus 5. In the place of x, simply we need to substitute minus 5. So minus 5 whole square plus 2. Minus 5 whole square, 25 plus 2, 25 plus 2, 27. So the value of g of f of 0 is equals to 27. So by this problem, first bit is completed. Now move to the second bit. Before going to the second bit, till now if you didn't subscribe to my channel, subscribe for more videos. Okay, the second question is, if f is a function from 0, 3 to 0, 3 is defined by f of x is equals to 1 plus x if the condition is 0 less than or equals to x less than or equals to 2, and 3 minus x if the condition is 2 less than x less than or equals to 3, then show that f of 0, 3 is a subset of 0, 3 and find f of f. So first condition is given as 0 less than or equals to x less than or equals to 2. 0 less than or equals to x less than or equals to 2, but that value is 1 plus x. Here we have only x. Observe clearly, here we have 1 plus x, but here we have only x. So still 1 is required for us. So that's why every term I will add 1. So here if I add 1, it will become 0 plus 1 less than or equals to x plus 1 less than or equals to 2 plus 1. So we will get 0 plus 1, 1 less than or equals to x plus 1 less than or equals to 2 plus 1, 3. This is equation 1. Next condition, 2 less than x less than or equals to 3. Here x is there, but here 3 minus x is there. Observe it clearly. This is x, this is minus x. So to get the minus x, I will apply minus symbol to everything, but if we observe the minus, the inequalities will change. So write in reverse. This plus 3 will become minus 3 less than or equals to minus x less than minus 2. Now we have 3 minus x. Here already minus x is there, so still we need 3. So that's why add 3. minus 3 plus 3 less than or equals to minus x plus 3 less than minus 2 plus 3. Minus 3 plus 3 0 less than or equals to minus x plus 3 less than minus 2 plus 3 is 1. Here minus x plus 3 is the same as 3 minus x. This is equation 2. So from the first equation and second equation we can conclude this, that is f of 0 comma 3 is a subset of 0 comma 3. Now we need to find the value of f of f. Let us check that. Here we have two conditions. The first condition is 0 less than or equals to x less than or equals to 2. So this first condition, 0 less than or equals to x less than or equals to 2, I will divide it into again two equations or two conditions. 0 less than or equals to x less than or equals to 2. So this condition I will separate into two conditions, like 0 less than or equals to less than or equals to 1. Here 1 is including because less than or equal to, so here 1 should not be included. So 1 less than x less than or equals to 2. 0 to 2 is there, so 0 to 2 I am dividing it as 0 to 1 and 1 to 2. Here 1 is including, that's why here I am not including. So 0 less than or equals to x less than or equals to 1 and 1 less than x less than or equals to 2. So first I will solve this condition, that is 0 less than or equals to x less than or equals to 1, and we need to find the value of f of f. So f of x, f of x, he gave conditions very clearly. So f of x value is 1 plus x. Again f of 1 plus x, again say very simple, 1 plus, in the place of x substitute 1 plus x. So we will get 1 plus 1 2 plus x. Now I am taking the second condition, that is 1 less than x less than or equals to 2. So again we need to find the value of f of x is equals to f of, same, f of x is 1 plus x. Now here the second condition is given as 3 minus x. So 3 as it is minus, in the place of x 1 plus x is equals to 3 minus into 1 minus 1 minus into x minus x. So 3 minus 1 2 minus x. In the second condition f of x value is 2 minus x. Now I am going to the third condition. Here the third condition is as it is, 2 less than x less than or equals to 3. 2 less than x less than or equals to 3. Then we need to find f of x is equals to f of x value is 3 minus x. Now f of 3 minus x, 3 as it is minus, in the place of x we need to substitute again 3 minus x. Oh sorry, in the 1 minus x we need to solve. So here this 3 minus x we need to substitute in the 1 plus x. So 1 plus, in the place of x 3 minus x. So we will get 1 plus 3 is equals to 4 minus x. So when the condition is 0 less than or equals to x less than or equals to 1, it is 2 plus x. When 1 less than x less than or equals to 2 is there, the value is 2 minus x. When it is 2 less than x less than or equals to 3, the value is 4 minus x. Okay, remaining problems we will discuss in the next video. Till now, if you didn't subscribe to my channel, subscribe for more videos. Thank you.